we need to get to it. Okay, so I'm going to start this slideshow, and we are going over stuff that we have done since last Friday. So you should have most of this in your notes, but we're going to go over something new today. I'm going to go kind of fast, so please pay attention. My expectation is that you're taking notes. Now, everything that I'm going over today is on ScatterPlots and a quick review on functions and how to tell whether something is a function. So if I call your name, please make sure, let me know what a relation is, a domain, a range, and a function is. I need those definitions. Today we're going to go over 8 SPA1. I can construct and interpret scatterplots for measurement data to investigate patterns of association between quantities. So that is a new lesson that you need to have in your notes. I will also be doing a notebook check tomorrow. You make sure you have 2 pages of notes to go in the notebook check. If you do not, you can go back and watch the videos. If you were not here, they are all recorded and you can get the notes from the videos. So here we're going to get into, first of all, what a relation is, what a function is, and what a domain and range are. So if I call your name, please answer the question that I'm asking. I'm going to call on you, April, Deja, Tyranny, Gabriella. I need to know what a domain is, a range is, a relation, and a function. So those definitions should be in your notes. Those definitions should be in your notes from yesterday, the day before, and from Friday, because I've gone over this exact same information all of those days. So please have your information ready. Already have your math spiral out, so we will not have to wait on you to go get it. Have your math spiral out, so when I come to you, you don't have to say, hold on, let me get my notes. No, you should have your notes already. It is my expectation that you already have your notes in front of you, because class is starting. You come to class prepared, and my expectation is that you already have your notes ready. Bobby? Make sure you have your notebook out.
Okay.
April, what is a relation?
A set of ordered pairs.
That is correct. A relation is a set of ordered pairs. Good job. Thank you. Deja, what is a domain? Tyranny, what is a domain? Oh, Deja got kicked out. Tyranny, what is a domain?
A domain is the X values of the order pair.
That is correct. Good job. Thank you. What is a range? Gabriella, what is a range?
The Y values of the ordered pair.
That is correct. The range includes all the Y values. Thank you, Gabriella. Good job. Thank you. So those are the 3 definitions that we've been going over and over. So every day I will ask a different set of people this same question, these set of questions, and I need you to know the answer. So Kelton, Keelan, Kamaya, Jordan, Bobby, when I ask you these questions, Justin, tomorrow, I expect you to know the definitions of a relation, a domain, range, and a function. Our last one is function. Bobby, what is the definition of a function? Bobby?
Oh, a function? Ain't it a relation or expression?
What do your notes say? Deja, do you have the definition of a function in your notes in front of you?
Not right now.
Okay. Jordan Strong, do you have a definition of a function in front of you?
No.
Okay, who has their definition of a function? Everyone should have their notes out, and you took notes on this the other day. So I expect everyone to have this definition. And I'll ask you
Can I
again.
say it?
Go ahead, Gabriella.
A function is a relation where every x value has one and only one value of y assigned to it.
That is correct. A relation, each domain value is paired exactly with one range value. Domain is the x, and the range is the y value. A relation or set of ordered pairs, a function is a set of ordered pairs, which is the word relation, where the x values do not repeat. I changed the definition just a little bit so that I could include this part so that no one would get confused about this. The x values do not repeat. That's one of the main ways you can tell whether these tables or the graphs are a function or not. Bobby, is this a function?
You call me?
Yep. Is this a function?
Yeah,
Well, how do you know?
because the x values don't repeat.
That is correct. What about this this black table here, relation? Amaya, is this a function?
It's not my notebook.
Amaya, going once. Going twice. Keelan Johnson, is this a function or not?
I checked it in the chat, Miss Knox.
I need you to open your microphone when I talk to you, Kamaya. Keelan, is this a function or not? Keelan Johnson, going once. Keelan,
I can tell you.
is this a function or not?
Yes, Miss Knox.
Kamaya, I'm done with you. I'm talking to Keelan. Keelan, is this black table, this relation, a function or not?
Yes, it's a function.
Why do you think it's a function? Why do you think it's a function, Keelan? What is the rule for a function? Read the first sentence at the top of the page to me out loud now.
Because the x values do not repeat.
Read the sentence of the definition for a function. Read it at the top of the page. Read the whole thing. I'm listening.
Function is a relation.
Relation where?
Function is a relation where the x values do not repeat. Each domain value is paired with exactly one range value.
Do the x's repeat in this black table?
No, ma'am.
Do the x's repeat in this black table? So you're going to look at the values under x. Do any of them repeat? Keelan.
Yes, they repeat.
What repeats?
The x.
Which x? Which one repeats? Which one repeats? Keelan, can you hear me? Which value repeats? You said it repeats. Which one repeats? We don't have time for this, Keelan. Kelton, which one repeats? Kelton, going once.
What was the question?
Which of the elements repeat in the x column? Is this a function, the black table?
No, it's not a function.
It's not a function. Why?
because the 1 repeats in the x value.
There you go. The definition there, Keelan said that you read, said a function is a relation or set of ordered pairs where the x values do not repeat. You said that they repeated. I asked you which one repeated. You could not tell me. We went to Kelton, who told me that the 1 value, the 1 repeats in the x column. That means it is not a function. That's what I was looking for. The red table here, Ladarius, is it a function? Ladarius going once. Ladarius going twice. Is the red table a function?
You said what?
Is it a function? Is it a function?
Which one?
The red table.
Yeah.
Why? How do you know?
Because the x values don't repeat.
The x values do not repeat. That means it is a function. Thank you, Ladarius. Good job. Okay, so we have a vertical line test that we talked about yesterday. And so when we look at a graph like this and we do the vertical line test, is this a function, Madison?
Yes,
It is. Why? How do you know?
because the x values don't repeat.
That is correct. So this is a function. All right, let's go to the next one. Here we have a table and an equation and also a graph. So they gave us a lot of information here. Michaela or Tavion. Tavion, is this a function?
Ma'am.
Is this a function?
Yeah.
What makes it a function? What's the definition of function? What is the definition of a function, Tavion? Did you write the notes from the last slide? What is a function? What do you have to have or not have to have a function?
You said what do I have to have?
Yeah. What makes a function?
Variables? Variable?
Is this a function or not? Tell me why. If anyone wants,
I don't know.
go ahead, Tavion.
I really don't know about this one.
Okay. So if anyone wants to help them out, please raise your digital hand. Victoria, is this a function?
No, it's not a function
How do you know?
because the x values repeat.
The x values repeat. Also, if we did the vertical line test, this would hit the vertical line twice. This graph, if we run it across, if it hits twice, it is not a function. You got that, Tavion? You understand? So if I ask you tomorrow the same graph, you'll be able to tell me, right? Good. So we also went over interval notation. That's when you can tell where the graph is and give us the lowest value and the highest value for that domain. So of all the x values for this graph is going to stop at -3 over here, and then it goes to +4 on the x-axis. So that means we're going to put this in brackets for interval notation, -3 to 4. So that tells us that this x value domain is going to be everything in between that. So our range also, we can do the same thing. We see that the range value on the y-axis, it stops here at the 2, +2 on the y, and then -4 on the y. So we're going to put the least number first and then the greatest number last. And so within those brackets for interval notation, we know that everything in between here and here are going to be included in the range for this equation, for this graph. Here is a little different. This is an absolute value graph. We're going to get into absolute value, but not today. The domain for this absolute value graph is negative infinity to positive infinity. In parentheses, it is important to know when to use the brackets and when to use parentheses. So here we see that once the graph goes out, it would include all of the numbers on the x-axis, the negative and the positive. So this is negative infinity and positive infinity. It looks like a number 8 to its side. That is the infinity sign. For the range, the graph starts right here. It doesn't go anywhere below this. So we can say it starts here. This is -2 on the y-axis. So since it starts at -2, we're going to use a bracket there. -2, then we'll use the positive infinity sign and end it with parentheses. That is interval notation. We also discussed function notation and what it means. We have gone over this, so I'm not going to get deep into it today. We need to get into scatter plots because we don't have much time. We have a shortened day. A scatter plot is a graph of a collection of ordered pairs. The graph looks like a bunch of dots, but some of the graphs are a general shape or move in a general direction. I'm telling you about scatter plots because this will be on your 10 ready. One thing that you should know, though, is that this is very, very simple and very easy. You already know how to do this. Kamaya, Nakia, Tavion, you already know how to do this. Because if you know how to plot points on a coordinate grid, then you already know what a scatter plot is. But I'm just giving you the definition of a scatter plot. So when you see it on your 10 ready called that, you'll understand what it is. So here, if you have a scatter plot, this is what it looks like. Someone has plotted a bunch of different points. There are X and Y values here. And so you can see all the dots on the coordinate grid. All right, here. And all of the dots look like they are going up, just like when we did linear equations and we had a line that was going up. We read these left to right. If I was walking from the left to the right, I'd have to walk up the mountain. That goes up. That is a positive correlation for a scatter plot if it goes up. A positive correlation will look something like this when you are reading word problems. If you look at the age of the child and the child's height, you will find that as the child gets older, the child gets taller. Because both are going up, it is a positive correlation. So both values are increasing. The age is increasing and the height is increasing. That is a positive correlation. Both values are going up. It is important that you know what a positive correlation is. If you miss any of these notes, please come back and pause the video so you can write the notes down. A negative correlation looks just like when we did the negative slope linear equations. We could tell whether it was negative or positive. Reading from left to right, if I was walking from left to right, I'd have to walk down this graph. I have to walk down. It is going down. It's decreasing. So this is a negative correlation. If the x coordinates and the y have one increasing and one decreasing, it is a negative correlation. If one value is going up, the other one is going down, we're going to have a negative correlation. This means the two are related as opposites. So they'll have one going up and one going down. That is a negative correlation. A negative correlation might look like this on a word problem. If you look at the age of your family's car and its value, you will find that as the car gets older, the car is worth less. This is a negative correlation. As you see here, the age of the car, 1, 2, 3, 4, 5 years, the value of the car goes down from 30 to 27 to 23, 5 to 18,700 to 15,000. That is a negative correlation because as the car years go up, the value goes down. That is a negative correlation. No correlation. When you see a scatter plot that just has a bunch of dots sitting on the scatter plot and you cannot find a pattern or any type of correlation that makes it look like it's going, you can't tell whether it's negative or positive or increasing or decreasing. They're all over the place. That is no correlation. There's no pattern. The points look scattered. There's no correlation. That means these two are not related. Please remember that for our 10 ready and your assignment for today. Here's an example of what that would look like in a word problem. If you see the size of the shoe, baseball player's shoe, and then their batting average, you will find that the shoe size does not make the player better or worse. Or I guess we could use that for basketball. Is LeBron better because he wears a certain shoe size? I don't know. I don't think so. But these things are not related. So this is a correlation definition, and you will see this in just a second. Measures the relative strength of the linear relationship between the two variables. It will be between -1 and 1. And some of them will be 0, so that it will range from -1 to 1. The closer to -1, the stronger the negative linear relationship. The closer to the positive 1, the stronger the positive linear relationship. The closer to 0 it is, the weaker any positive linear relationship it is. So here, if you see this type of graph on your 10 ready, which scatter plots below show a linear trend? You know what the word linear means line. You know what scatter plots are because we just talked about them today. If you see this and they ask you which ones show a linear trend, so these three are in such a close proximity to each other that they look like they could form a line. That means they have a linear trend. This one is going down, so it is a negative correlation. This one is going up. That means it's a positive correlation. And this one is going straight across. It looks like the dots are making a line straight across. That is a constant correlation. So that's what that means when you see those. So if you see this on 10 ready, this is what this means. Now we can't do anything with A, B, or D. Why? Because they are scattered. There's no pattern. We can't tell anything. We can't see a pattern. We can't tell whether it's negative or positive or increasing or decreasing. We can't tell anything. All the dots are all over the place in no type of order. We can't tell what's happening here. So that is usually a no correlation. So we're only going to pick C, E, and F because they show us positive, negative, and a constant correlation.
Miss Knox, it's time to leave.
And here are the the coefficient correlation values I just told you about that go from -1 to 1, and then the zeros. This is what you will see. So this, I gave you the definitions of what that means. You have the -1 there. That means it is closer to the positive correlation. The negative correlation. If it is a positive one, it is closer to the positive correlation. And then here you have a -0.6 and a negative or a positive 0.3 that is in between the 0 and the 1. Then that means that it is either weaker. This is a weaker form of this one, and this is a weaker form of the second graph down here. Or you can have the relation be 0. These are both zeros. These are very, very constant. So here are two examples of your data plots. If you the scatter plot that you have put data on, the trend here seems to be increasing. This is a graph on vehicle sales and the years. It looks like from this graph, and I could be able to tell someone if they ask me to interpret it, what is happening on this graph. I would say, well, as the years go on, the sales of vehicles has been increasing every year. So as the years continue increase, the sales increase. So business people use these in real life to be able to predict what will happen the next year. If you have a positive scatter plot of what is happening with vehicle sales, you can predict what's going to happen in 2001. If they all have been going up at a certain rate every year, you can tell whether it's going to go up that next year. It's very important to know how to do that. It is in statistics. If you are interested in jobs in statistics, then you will make a lot of money. They are in high demand. Okay, so we are out of time, but I want you to make sure you go to your Go formative for today's assignment, which is already in the assignment queue. The assignment queue. Then you can work on that assignment. You are dismissed for the day.